Okay, assalamu alaikum everyone. Can you hear me? Hello. Hello, can you hear me? Okay, thank you. So we'll start our this session. Okay, sorry for delay. So let me share my screen. Okay, can you see my screen? Is it visible? Okay, so let's go. Okay, so basically today is our sixth number day. Basically today I discuss about that machine learning in Google Earth Engine. So how we can really apply different types of supervised, unsupervised, this type of machine learning method in Google Earth Engine and create the land use land cover classification mapping. We also discuss about that and how to check the accuracy assessment of your land use land cover classification. We also discuss about that and how to export the GeoTIFF file after creating the land use land cover. Then further how we can easily use the ArcMap to create the map for our research paper presentation. Okay, as well as how to calculate the area. Okay, so this type of things we discuss about that. And before studying the machine learning, first of all, I discuss about that how we can easily create the annual image collection because it's very important. So when you work with historical land use land cover analysis, suppose I want to start the analysis from 1980. Okay, so 1980, then suppose 90, then 2000, 2010, or 2020, or 2025. Okay, so for that we need to merge Landsat 5, Landsat 7, Landsat 8, or Landsat 9. So all of image collection we need to merge, and further from here we need to create the annual composite. Okay, suppose for year of 2000 or 2025, 2000, 2010, or different year. Okay, so first of all I try to show you that how we can easily make the annual image collection and merge all of satellite for Landsat. Suppose Landsat 5, Landsat 7, Landsat 8, Landsat 9. So these three satellite we try to merge all of image collection and further we create the median composite. Okay, then we start the machine learning part and then create the different types of land use land cover classification. Okay, let me open my code. So first of all, you simply import your study area. So in this case, suppose I want to merge Landsat 5, Landsat 7, Landsat 8, Landsat 9. Okay, so this fourth satellite I simply merge. Okay, and suppose I need the image from 1980 to 2025. Okay, so every year, okay, from 1980 to 2025, so every year I need the median composite. Okay, for Landsat. So it's very important when you work with the historical data analysis for your research paper, not only for the land use land cover. So when you work with NDVI time series chart, or when you work with LST time series chart, so this type of things we can easily work using this way. Okay, so we need to just make the image collection, annual image collection. Suppose I want to make the time series chart of LST, then this process you can also follow and make the and merge the different Landsat image and create the annual composite from 980 to 2025. Okay, you can simply create. So let's go ahead and show you that one by one, all of those. Then further we try to use the image and make the land use cover classification help of machine learning. So first of all, which area you need to image? So simply import your shapefile boundary. Suppose I need to work with Dhaka city boundary. To simply import the Dhaka city boundary, and I put the name as a You can put any name. I put the name suppose AOI, area of interest. So now we simply take our satellite images for different time period, and before that we simply set the observation year. Suppose I take a variable start start year. It will be start suppose 1980. Okay, and suppose in year I put suppose year of 2025. Okay, so this is my observation years. Okay, so I need this every year satellite composite. So first of all, we need to check our satellite images. We need to work with Landsat 5, Landsat 7, Landsat 8, and Landsat 9. So basically Landsat 8 and 9. So these two satellite, all the bands are similar. Okay, Landsat 8 and 9, if you check, all the bands are similar. Mainly, and Landsat 5 and 7, these two satellite, all the bands are similar. Okay, Landsat 8 and 9 and also Landsat 5 and 7, these bands are similar. If you check, so I'll show you practically. Just open the data catalog and show the Landsat. If you check the Landsat 8 and Landsat 9 are the similar bands. Okay, surface reflectance or top earth, it is the same similar bands we find out. But land use, land cover, we had used the surface reflectance. Click on here. So if you check, we find out SRB1, SRB2. So all of bands, basically you can see B1, SRB1 it's a aerosol or coastal aerosol. Then blue, green, red. Okay, we find out the same sequence also for Landsat 9. If you check the Landsat 9 surface reflectance, we find out the same sequence for B1 is the coastal aerosol, then blue, green. Okay, B5 is the near infrared. Okay, now if you check suppose Landsat 7, if you check suppose surface reflectance, if you check for the surface reflectance, if you check the band 1 is the blue band. Okay, but for the Landsat 8 and 9, we find out that band 1 is the coastal aerosol band. Okay, so it's the some difference between the Landsat 8, 9 and Landsat 7. Okay, you can see band 1, then band 2, band 3. Band 3 is the red. Okay, for Landsat 7, but for Landsat 8 and 9, band 4 is the red. Okay, and you can see in this time band 4 is the near infrared, but for the Landsat 8 and 9, band 5 is near infrared. Okay, so this type of difference we find out. And Landsat 7 and Landsat 5 is the similar sequence. If you check the Landsat 5, we find out the similar sequence with Landsat 7 band. If you check the surface reflectance, so
what is the difference between level 1, level 2, tier 1, tier 2?
Okay, so this is the level 1 is the previous version, level 2 is the more updated version. Okay, collection. Okay, for the tier 1 and tier 2, it's the previous version, update version. Suppose previous time we are also using at the level 1. Okay, so you can see L2, previous time it was L1. Okay, but now it also updating further and create the new collection for level 2. Okay, now level 1 dataset is not available in the Google Earth Engine data catalog. Okay, so some in the future time we also find out the level 3 also, level 4. So it is also updating this type of image collection in Google Earth Engine. Okay, and previous image collection was deprecated. Okay, it's just removed from the data catalog, and day by day it also updating this type of image collection, level 1, level 2, then level 3, level 4, or tier 1, tier 2. So this type of things you can see we find out the similar bands for that your Landsat 5 and 7 is the similar. So now we first of all we need to create the bands. Basically I want to merge Landsat 5, 7, 8, 9, all of image collection I need to merge. But if we notice that the Landsat 5 and 7 are the similar band, but Landsat 8 and 9 the similar. Okay, so these two satellite bands are similar, and also this Landsat 8 and 9 as the similar. So now how I can combine the all of image collection? Okay, so for that we simply set the take a variable. Suppose I put the variable name is that Landsat 5 band. So I just put the band, and I just make the list all of Landsat 5 band. Okay, basically we find out the Landsat 5. If you check for the Landsat 5, we find out this type of band: SRB1, SRB2, SRB3, SRB4, SRB5, SRB6. Okay, so now SRB blue, green, red, near infrared, so this type of them. So we simply write the name of all band name. Okay, and also take the another variable, suppose Landsat 7 band or band. So we just put the band. So you can put any name as a variable equal. So now I just simply put the similar band, because Landsat 5 and 7 is the similar bands. Okay, so just we simply write the Landsat 5 and 7 bands. Suppose first band is that SRB1. Okay, both are the bands same. Then SRB2, then SRB3, then put here SRB4. Okay, then if you check for 5 and 7. Okay, 5 and 7, 5 and 7. So simply put here that SR5, and also put the SRB7. So this is the bands. So now we also mention the band name. Suppose take another variable L5 names. Okay, and we make the list all of band names. So take the variable L7 names, basically similar. Okay, so that's why I simply write at the same time for the Landsat 5 and 7. So now put the name. So suppose first band SRB1, it's called the blue. Okay, I put here the blue. Then SRB2 is the green, I put the name green. Then SRB3 is the red. Then SRB4, it's a near infrared. Then SRB5 short wave infrared 1, SWIR1. And SRB7, it's a short wave WIR2. Okay, so we simply take this band. Okay, so we take the Landsat band name and also take the Landsat band, then we take the another list for the name. Suppose SRB1 is the blue, SRB2 is the green, SRB3 is the red, then near infrared, short wave infrared, and short wave infrared 2. Same for the Landsat 7. So now we take the similar way, we take the band name for Landsat 8 and Landsat 9, similar. Okay, Landsat 8 and 9. So just take a variable, suppose L8 bands, and also take the variable L9 bands. Okay, so now you put the band name. So in this case, if you check, so one extra band we find out in the Landsat 8 and 9. This band name is aerosol, coastal aerosol. SRB1 is the coastal aerosol for the Landsat 8 and 9. So in this time I start from SRB2. Okay, so I just start from the SRB2 because I need to create the composite help of all of image satellite image collection. So that's why I need the similar bands. So it will be start from SRB2. Okay, which is indicating the blue band. Then I put here SRB3, then SRB4, then we take SRB5. then SR B6 and SR B7. Okay, so now you put the name. So for that, just take the another variable, suppose L8 names equal, and take the another variable in here for L8 names for L8 L9. Okay, so now make the list, just put the name. So first it's a blue, then it's a green, then red, then near infrared, then short wave infrared 1, and finally short wave infrared 2. Okay, so SRB to blue, then green, then red, then near infrared, then short wave 2, and short wave 1 and 2. So now if you can check, we find out the similar band name. You can see for the Landsat 5, Landsat 7, Landsat 8, Landsat 9. So all bands name are similar. So now I can easily use this type of band name, and I can easily make the composite help of all of satellite image collection. Landsat 8, 9, 7, 5. Okay, I can easily create. So this is the first step to select your bands this way. So now you can see the first band is the blue. Okay, all of satellite first band is the blue, second band is the green, third band is the red, fourth band is the near infrared, then fifth band is the short wave infrared 1, and sixth band is the short infrared 2. Okay, last band, you can see all of last band is the short infrared 2, similar. So I create the similar all of bands. So now I can easily use it and make the image composite or different types of analysis, LST times Richard or LST mapping or everything we can do. So let's go. And as well as if you check, another important thing is that all of image collection have a similar band for cloud marks. Okay, for removing the cloud. So this band name is the pixel QA. Where is it? SR Cloud QA. I think they also changed the band name, but previous time it was Pixel QA. So now it's a SR Cloud QA. Okay, let me check for Landsat 7. What is the name? It was Landsat 7. So it was SRQA. Okay, so recently it changed, but previous time it showed the Pixel QA. Okay, cloud shadow. Okay, so I think when I discuss about that cloud remover function, so then I think we also use the Pixel QA pen. Okay, it also, yeah, it also available the pixel QA pixel. Okay, you can see this one QA pixel, so it also available, but now they're also add the another things SR Cloud QA. So I think this bitmarks is also help you to, you can see fast bit, dark dense vegetation, cloud shadow, snow water. So this is the another bit. It also help you with the cloud quality assessment. Okay, and we also find out the another band QA pixel. Okay, if you check that suppose Landsat 5 again. So below the yeah, so this one, yeah, QA pixel. Okay, so it's also available, no problem, also use it. So all of satellite, it can be Landsat 5, 7, 8, 9, the similar band name for pixel quality attribute or cloud, creating the cloud remover function. So just I simply also mention this band because it is similar band for all of image collection Landsat 5, 7, 8. So just mention the band. QA pixel. So now we'll also mention about the QA pixel. So this is the cloud remover band. So this band we also need to remove the cloud. Okay. So now after creating this type of things, we need to filtering the satellite image collection. So first of all, we need to call the L9 or Landsat 9. Landsat 9. So take a variable, suppose L9, and call this image collection for Landsat 9. Surface reflectance. Just copy. Okay. And then simply filter. Okay, we'll learn about that. Filter bounce with AY. Then put the filter date. So we are just simply take the date from here. I take the full time period which is available 2021 10:31. It will be start from here, and available time last time 2025 094. Okay, so just put the time period, and then we put the select function. Select the Landsat bands and also select the Landsat band names, because all the names are similar for different satellite. Okay, so now take that another, suppose filter metadata you can also use. Suppose I put the cloud cover less than, suppose I put here less than 1, but sometime suppose you try to put the 1, but some year, suppose 2000 or sometime it show the 0 value. Okay, 0 value means that less than 1% image is not available. So it's the better way. We try to keep, suppose high cloud cover, suppose 60% cloud I just take, and further this 60% cloud I just need to remove the cloud using the cloud remover function help of this band. Okay, because sometime less than 1% image or 2% image 5% image is not available some study area. So that is the reason you try to take the high cloud level, and further this cloud level simply remove using the cloud max function. Create a function, cloud remover function, and then remove. Okay, so I put the 60% cloud, and now I need to create the cloud remover function. We already know about that, how to create the cloud remover function for. Okay, so let's go try to create the cloud remover function. So take a variable, suppose I put the variable name is that max or remove cloud, okay, and cloud remover function is the similar Landsat 8 and 9. Okay, for the same bit, Landsat 8 and 9 are the same bit. Suppose cloud shadow, this type of bit number are similar for the Landsat 8 and 9, and Landsat 5 and 7 are also similar for the bit number. Okay, so we create a function. We just create the one function, and this function further we can easily apply Landsat 9 and Landsat 8 easily. So we create the another function for the Landsat 5 and 7. We can easily use this function for cloud remover. So let's go try to create a function. Call the band name QA pixel, and take a variable. Suppose I put the variable name is that cloud shadow bitmax, and this bit number for the Landsat 8 and 9 if you check. So for the Landsat 9 the cloud bit number is the 3 and 4. Okay, cloud and cloud shadow. Okay, 3 and 4. 3 and 4. Cloud shadow for 4 and for the cloud 3 for the Landsat 9. Just I put here suppose 1 less than cloud shadow. I put here 3 4. Okay. Then take another variable, suppose cloud bitmax 1 less than put the 3. So now take a variable suppose max and call the QA, connect with your bit. So put here the bit wise and function and call the bit number, suppose cloud shadow bit max, then set equal to 0 signal, and same process and call the QA, connect with bit wise and with the cloud bit max and set equal to 0 signal. Okay. So now just use it and return this image update max using this condition. Just copy the variable name because this variable is stored at this condition. Okay, so now this is the function. Okay, cloud viewer function. So this function I want to connect with my image collection. So further, if I just increase the cloud level, this cloud is not affected my image composite. Just put here dot map and call the function variable name. Okay, so now Landsat 9 is done for filtering. So we are just applying the same process and filtering for Landsat 8. Just I copy same line of code and paste here. I take suppose Landsat 8 and for the it will be Landsat 8 correlation to tier 1, and further let's check the time period for the Landsat 8. So 2013 318, just take copy. So this is the start time and in time is 31. Okay, and I put the variable name suppose L8. So now we take this Landsat 9 and 8. So now same process just apply and also change the band name. It is Landsat 8 L8 bands and L8 names. Okay, so others keep the similar. So now take filtering for Landsat 7 and 5. So take first here I put, so this is a Landsat 7 and it will be Landsat 7. Okay, and then further put it's a Landsat 7 bands and Landsat 7 names. Okay, as well as we need to change the time period for the Landsat 7. Surface reflectance, and I want to use suppose this okay, it's a LE. Yeah, sorry, it's a LE. Just I copy and change the paste here, and then time is available. It start time. And it's a in time. Okay, now if you check suppose Landsat, what is the name for cloud and cloud shadow? So now you can see it shows the similar cloud 3 and 4. Okay, so 3 and 4, but previous time it was different. So now they are keep the same bit number, cloud and cloud shadow 3 and 4. So not need to change. Okay, QA pixel same band name and also same 3 and 4. Okay, bit number. So we are just keep the same cloud remover function. There is no problem. Okay, so now take this another for the Landsat 5. So just put here the Landsat 5 and then call the Landsat 5 snippet ID. So this is the last time in 1984. Okay. Put the Landsat 5 and Landsat 5 names. Okay. So now this is our time 1984. Okay, but when you need the data set suppose 1980, then I think we will also need to merge the another satellite Landsat 4. Okay, this thing we also need to, it's 1982. Okay, all Landsat. So you also try to this type of image collection, you also try to merge. Okay, because you can see its last time is the 1984. Okay, so we can get the image suppose 1985 to present. But when you work with the more past time, then try to also use this type of Landsat 4TM and also Landsat 125 ms, then just combine. Okay, so but this is the process for combining. So now we create the merge. So after taking the image collection for the Landsat 5, 7, 8 and 9, so take a variable, suppose full, I put full collection. So simply merge all of collection. So Landsat 9, 8 merge with Landsat 8. Okay, then it's merge with Landsat 7, then merge with Landsat 5. So now let's check how many images we find out the full collection. Just take copy and run the code. This is the total number of image collection we find out. And now okay, so we find out this is the total number of image collection. So now this image collection we just need to convert into annual. So how we can easily convert the annual? So a lot of time I discuss about that, how we can easily create the annual time series chart or monthly time series chart. Suppose I have a image collection, so this image collection I convert into another image collection. Suppose I have 1350 image collection, so this 1350 image collection I need to convert annual. Okay, annual image collection for a range of specific years, suppose to 1992 present time. Okay, so let's go how we can create this type of annual image collection. I'll try to show you that. So this is my total image collection. So this image collection I need to convert. So take a variable, suppose annual collection. So this annual collection I want to convert annually median composite. So we just use e dot image collection from images. Okay, so this function will help you to convert. Suppose I have a collection, this collection I convert into other image collection for a specific range, suppose for annually or monthly, this type of things. So this function is simply use e.image collection from images, and now we create a function, and using this function we filtered this full image collection annually for a specific year. So for that we create a function. Suppose I create a function, I put the function variable name suppose y, and now what is my argument using this y? So my argument is that I want to filter this full image collection using the element of y and create the median composite. So for that create a variable, suppose annual, and then call the full collection. So this full collection I want to filter. How I can filter? Yearly. This is my target, yearly. So put here filter, earth engine filter, calendar range, it will be year, year to year, and unit is year. Okay, just we simply define the unit. So after filtering yearly, then we create the composite. So I create median composite. Again, further I want to clip with my study area, which is AOI. Okay. So after this step, what I return from this function, we need to define. So just put here the return. I want to return this annual. It will be annual. It's set with year. Element is y. So now this is the function. So in this function, I need to define the year sequence. Okay, suppose I just make the year start year and end year. Okay, and make a sequence. So using this sequence, I can simply find out, suppose one by one, suppose first year, second year, third year, fourth year, all of year one by one come in this function and filter and create the median composite. So for that, we already define, you can see already defined that start and end year. So now we are just use it and make the sequence, just make a list. Okay, so from this list, one by one year is come in this function and compute. Suppose first of all, suppose 90. So this year come in this function and check how many images. Suppose I find out 5 images. So using the 5 images and create the median composite. Then suppose 9091. So this year image collection simply come in this function and check, suppose there are the total 3 images. So this 3 images create the median composite and clip with my study area. So just it comes from our sequence. So let's go try to put the sequence, and in this case I just put here suppose 990 and make the sequence. Suppose I put the take a variable years and put ee dot list dot sequence, and this sequence it will be start from 990 and end year 2025. Okay, so now this variable is stored all of years. So just I copy, and this variable I need to connect with my function. So this is my function. So these things I need to connect with my function. Okay, so for connecting, just paste this variable. Okay, so this is my years. So basically this variable is stored all of years. Okay, and I connect with this function. Okay, this function for connecting, use the map function. Start the bracket and also close the bracket. So this is the function. So now what happened? So now this function, this from this variable one by one, suppose 990, just input in this function and filter yearly and find out suppose 3 images. So this 3 images create the median composite. Then next year. So one by one up to 2025, all of year come one by one and create the median composite yearly. Okay, so now we try to check how many images we find out. If you check, just print and call the annual collection, just run. So in this time it show the all up with total 36 years. Okay, total 36 years we find out the image. 1990 to 2025, total 36 years we find out the image annual composite. So you can see first time I find out this is my image collection 1350. So this image collection I just convert 36 images, okay, by annually. So this is the process for converting. So now suppose you want to make the annual NDVI. So just simply create the band of annual NDVI and connect with this image collection and make the NDVI times reach chart for annual. You want to make suppose LST, annual LST times reach chart. So for that, what you can do, just create the band of LST and connect with this image collection and make the time series chart. You want to make NDVI time series chart, same process, just make the NDVI band and this band simply connect with your image collection and then you can create this band. So if you check, we find out. So now you can see some years it show the 0. Okay, you can see the 0 bands. 0 bands, it means that there is no image. Okay, we got the image from what the time 1990. Okay, you can see all of are the 7 bands, but only we find out this type of place, this type of year. Suppose you can see first year 1990, it show the 0. 0 means that there is no image. So now how I can get the image? So one solution is that we just increasing the time period, we increasing the cloud level. Okay, suppose let then check what happened. Suppose Landsat 8, we just increase. Suppose Landsat 7, increase suppose cloud level suppose 80, and also increase suppose it also 80. Okay, now run check what happened. So then check again what happened. Okay, still show. We find out the last 1990. So now let's check suppose 90% cloud, or is there any mistake that the reason it's not showing the image? I don't know. So let me check. No, it show the result from 1990. Okay, but other image not showing. We make a mistake. This mistake is that we keep the similar Snippet ID, Landsat 7 and Landsat 5. We keep the similar. So let me change. Landsat 5, it will be different. Let's just copy the snippet ID for Landsat 5, change the previous one because you can see it said Landsat 7. Again paste here and run the code. Now let's check. So now, yeah, so now we find out all of, you can see for the first year 1990, second year 1991, and up to 2025 we find out. Okay, so now, okay, let me just try to keep the low cloud cover 60%, then check what happened. Okay, so we always try to get the low cloud level. Okay, if this there is no, then we try to increase. Okay, so it also available, no problem, we try to use. Or if you check suppose 40%, 50%, or 20%, or 10%, if the available, then we try to use it. And if the low cloud level is not available, then try to increase the value one by one, just increase. So now image is available, you can see all of images, you can find out. So now I just try to visualize this image. And another important thing is that this type of image, basically this type of digital number, we need to convert into reflectance value or wavelength. Okay, and if you check, we find out this type of scale and offset value. So it also used to get the better reflectance value. Okay, so let's go. I'll show you how we can easily use this type of value. So now I want to use this type of value, and this type of value, scalable and observable are the similar. Landsat 5, 7, basically band 1 to band 7, all of bands are the similar. For the Landsat 5, 7, 8, 9 are the similar scalable and offset value. So now we can create a function. Suppose using the function, we can simply connect. Okay, so let me try to create a function. So let's take a variable. Okay, let me show you that from here. Yeah, just we are using this code. Okay. So in this code, okay, so they are write this type of way, but we also try to suppose this thing, it's a variable name, function variable name. So just we define suppose var keyword and paste. Okay, similar. Okay, so this is a function variable name. So we create a function. I put the element name image, and further we create the curly bracket. In this curly bracket we just put our argument. So what is my argument? So all of optical bands, basically all of b1, b2, b3, b4, b6, b7, b8, all of bands, we need to multiply this value and add with the offset value. Only for the one band, which is stb10. Okay, sometime it also show the stb. Okay, in this time we are just ignore this time, because stb10 and stb6 it's create the another problem. Okay, so we also try, suppose SRB. Okay, if you want you can also mention, suppose just put here also another band, STB10 band. We also try to define. Okay, suppose we create the band name, basically Landsat 5 and 7, the band name is the STB6. Okay, and for the Landsat 8 and 9, this band name is STB10. Okay, so now this band I want to keep the similar name. Okay, all of those. So just I put the name, suppose. So I put the name. Suppose you can put any name, or brightness, temperature, or BT. So I put, suppose, BT. Okay, similar band name we can put the similar band name BT. Okay, but you can see STB6 and STB6, this band name Landsat 5 and 7, and STB10 Landsat 8 and 9. Okay, but we put the similar band name for all of image collection of Landsat. Okay, so now from this image we are just select the BT. So I put it's a BT. Just we merge. Okay, let STB6 and STB10 merge and put the name BT. So now SRB. So this symbol means that it including all of SRB1, SRB2, SRB3, all of those. Or if you want, you can also make the list. Or I think it also better we try to put the name, because we keep the same name. Okay, all of band are the same name. So from here I just take only for the multispectral this type of bands. Just I copy the all of bands and then I create a list, then it will be more perfect, and paste here. Okay, so now this type of blue, green, near red, near infrared is multiplied with this value, also add, and also brightness, temperature also add. So now this is the function. So this function I need to connect with my image collection. So I just connect with the dot map function and connect with Landsat 9. Also connect with Landsat 8, Landsat 7, and Landsat 5. So now let's check what happened. Oh my god. Cannot read properties. Okay. Type error. Cannot read properties, null, reading type. Okay, what is the problem? Okay, so suppose if I just put the . suppose SRP1. So now let's check. And which line we have problem, it also need not notice. Okay, collection. Okay. Yeah, okay, so just I try to use the same. So update marks this condition, we just add, suppose multiply 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 this and add with negative 0.2. So we are just only what for the multispectral, suppose optical thermal we try to add later. So further I simply define return marks, this update image condition I simply multiply with this scale value and offset value, and then we are just copy properties of this element and put here system time start. Okay, so now let's check what happened. And okay, just run that code, and we keep only for the one function. Okay, cloud remover function will say add the your reproject the script value. Oh my god, what is the problem? Oh, we put the 2 comma sign. So it also worked. Okay. So now let me check both bands, suppose optical and thermal. Okay. So now it also reprojected only for the optical, but I want to apply for optical and also thermal at the same time. Okay, this is our this type of optical bands, and these are thermal band, and I put the same BT. Okay, so now I hope it will work. Previous time it showed the problem for double comma sign, and I just also comment this. So now just uncomment this line. So now at the same time, we just simply work with STB10 thermal band and also optical, all of optical bands. Okay, so it worked. So now we can easily use the LST monitoring, because when you make the LST time series chart or LST monitoring, you need the thermal band. So now we at the same time we just simply work with our optical bands and also work with thermal bands. So now it also help you. Suppose using this image collection, you can make the annual time series chart of LST or annual LST map. It also help you. Okay, because at the same time we add this type of thermal bands and also reproject their pixel value. Okay, so from 1990 to 2025. Okay, so let's we try to display now image. Okay, so this is the process to working with Landsat 5, 7, 8, and 9 and create the annual image composite. So I take a variable. Suppose I put the variable name is image 2000, or if you want you can take the another way. Suppose just map.add layer, and call the annual collection and apply the another function called the two bands. Okay, so basically this function help you all of image. So let me show you the result just on the code and also focus on our given study area. Center object is AOI. So now at the same time we find out all of image. Just click on here, and if you check the band, it just show only for the bands. You can see for the blue, green, red, near infrared, short infrared, 2. Then for the one, suppose this is the blue for your 90, okay, 0, because 0 is the starting. And if you check last is the 25, okay, or we find out the 35 blue. Okay, this blue band, it's basically in year of 2025 for the blue band. So let me try to add the composite. Suppose 3-band composite. Suppose I take the blue, green and red. So when I put the 0 mainly in year of 2000 and 1990 first year, and I customize for 98% and apply. So now we find out the, sorry, I need to put here the RGB, mainly red, green and blue. So 0 indicating about the year of 1990. Now apply. So now we find out this type of imagery, and this is the image in 1990. Okay, in Dhaka city. Suppose you know display the image for 1991. So then put the 1991. So one blue, one for green, red. Then put the one for green and one for blue. So now we find out the image in 1991. So keep the stressing 98%. Apply. So this is the image for 1991. Okay. And now suppose I want to work for 2025. So just simply go to the last 2025 for blue. So red, then select for the red, green and blue. So this is the one process to visualize all of images, but we also try to create the variable and store it this type of image. So red, green and blue. So now it display the imagery in year in 2025. So this is the image in year of 2025. But we try to create a, so let's take a variable. Suppose I need the image. Suppose I have this type of annual image collection, but I don't need all of image. So I need suppose a specific time period. Suppose I need the image in 1990, then 2000, 2010, 2020 and 25. So how I can filter? So just take a variable, suppose image 1990 equal. So call the annual collection. Okay, and if you check suppose annual collection property year 1990, so just filter. So filter, how I can filter? Earth engine dot filter equal, what's equal what? Year equal to this number, this year. So put here the year 1990. So now this variable stored the image of 1990, but I want to create the composite. I apply the mosaic composite. So now we try to display. Suppose just map dot add layer and add the image 90 190 and run the code. So now try to add the visualization. So you can see, find out this, not this, this one, yeah. So I put here suppose red, brain, and Fulu. Stressing, keep the 98%. Apply and import. Then copy and it's not need, just a comment, and put here the visualization, and I put the 90 layer name. Okay. So then I need the image, suppose another year. So just use the same code, I paste here. I put the image, suppose 2000. Okay, 2000, and set the year equal to 2000. Okay, now I want to display it. So just you just add the layer. So map dot add layer, call the image 2000. So now you can use this type of image and make the NDVI map or LST map. Okay, so which type of process I already show you, you can also try to apply this type of images also and make the analysis for the historical data analysis. So if you check now, it add another layer for image 2000. Add the color red, green, and then further import. Paste here. It's a 2000 layer name. Then I need suppose 2010. Just copy and put here 2010 and set equal 2010. Then apply map.add layer, same process, image 2010 on the code. So finally I take the image for 2020, or you can also take the 5 years gap, no problem, 5 years interval or 10 years interval, or every year. Basically I have the image total 36 years from 1990 to 2025. From here any year I can use and make the analysis. So 2010, so now 2020. Image 2020. That was 2025. Okay. For 2025, and now display. It's 2020. Okay, so this is the process to working with merge Landsat 5, 7, 8, or 9. And further, we can easily apply this type of image collection for different types of historical data analysis, suppose land use, land cover, or LST, or NDVI analysis, any purpose we can use. So now I can see here I add the total 5 images. So now suppose you want to make the land use, land cover change detection using the total 5 different years. Okay, so lot of scientific paper you can check, we find out this type of topic they are used, make the land use, land cover change detection again for the different time period. Okay, and also LST for the different time period. Okay, so this is the process to get the image merge with Landsat 7, 5, 7, 8, 9. This concept you can also use for the Sentinel 2 satellite imagery. So Sentinel 2 we can easily create the annual, suppose from 2017. Okay, suppose Sentinel 2 is available multispectral, we can easily apply and create the high resolution, but it will be start from 2017. Okay, we can get the data, but for the landscape we find out the historical data, so it will be start from 1975. Okay, but some place 1975 in the year, some place have not image. Okay, but we find out, you also try. So then basically for the 1980 or from the 90 we can get, for any study area we can find out the image. So this is the image you can check. So this is the image that we find out in Landsat. You can see 2025. Okay, so this is the image for 2000, this is the image for 2010, this is the 2000, and this is the 90. So now we can use this type of image for the different purpose and make the historical data analysis and also change the trend analysis. Okay, so now from this image I just show you only for the one image to make the land use, land cover classification. Same process you also apply to create the others land use, land cover classification for 2020, 2010, 2000, and 1990. Okay, so same process you can also apply for the suppose LST. Okay, we already discussed about that, how we can easily make the land surface temperature and also urban heat island, okay, or urban thermal field variance index. So this type of things you also try to apply. So this is one kind of your assignment or your homework. So you also try, suppose you try to make the LST using 2025 this image, 2020 also make for LST, or 2010, 2000, or 1990. Okay, as well as you also try to make the annual time series chart of LST or annual time series chart of NDVI. So just practice, and further face any problem you can get the lifetime teaching support regarding this type of course content. When you face any problem you can get the support, okay, for the free, inshallah, for the lifetime. So now we discuss about that how we can easily make the land use, land cover classification. Okay, for the I just show you only for the 1 year. So same procedure you can also apply for the others and make. Okay, so in this time we discuss about the land use, land cover, how we can easily make, as well as how we can easily calculate the area, as well as how we can easily check the accuracy of your land use, land cover classification, and how to increasing the accuracy. Okay, so in this time for the machine learning we discuss. So in the machine learning there are a lot of benefit to use the land use, land cover classification, and we can easily train our model using the machine learning. We can easily train our model, so using two way. One way it's called the supervised model. Another way it's called the unsupervised. So simply in the supervised learning, okay, mainly we piece our model, or we can also train our model. Okay, train our model. Okay, suppose I just supervised this model, or train our model, or teach our model. Further, it gets some knowledge from my experience, and further machine just learn this experience and then apply. Okay, so in the supervised learning, you need the training sample. Okay, training sample. Okay, training samples. When you make the supervised learning, you need the training sample, or when you train your model, you need the training sample, or when you teach your model, you need the training sample. So what is the training sample? Training sample, basically it stored the class. Okay, it stored the different types of class with their label. Suppose I want to classify it from this satellite image. Suppose in year of 2025, I want to classify it from this imagery. I want to classify it, suppose build up. I want to classify it, suppose water body. I want to classify it, suppose uh, vegetation. I want to classify it, suppose fairland. Okay, you can add the more class, suppose cropland, others. Okay, then you just need to take the training sample for each classes. Okay, and how we can easily get the training sample properly, so I'll also discuss about this thing also, then you can easily get the idea to collect the training sample. Help of different types of pen combination we'll also discuss. So first of all, build up, water, vegetation, barren land. So for this type of class, I need to take the training sample, because now I teach my model. Suppose I teach this is the build up. I teach my model, this is the vegetation. I teach my model, this is the water body. I teach my model, this is the barren land. So then this model just use their own experience and further make the full land use land cover classification and identify the water body, identify forest, identify vegetation, identify barren land, identify water body, everything. Okay, so this is the way we need the training sample, okay, to teach our model. But for the unsupervised, we can also use, this is another model for teach. So unsupervised learning not need training sample. Okay, or not need pre-categorized data. Suppose in this for the supervised model, we just simply pre-categorize. Suppose build up is on my one category, water body, vegetation is one category, barren land is one category. But for the unsupervised learning, not need training sample, as well as also not need pre-categorized data. Not need. Just unsupervised learning, find out the similarity, okay, from my pixel and identify the different class, okay, using clustering. So both of model I discuss and also show you the practical example, then you can easily get the idea how it will work for the supervised and unsupervised learning. So first of all, supervised. So when you apply the supervised, first of all you need this type of image. Okay, and how we can easily get the yearly or annual image combine of the Landsat 5, 7, 8, 9. I already discussed about that. So now suppose I want to use this image and make the classification. Okay, so and classify different classes using help of supervised learning. Okay, so when you apply the supervised learning, first of all we need to create the data set. Okay, so in the data set, okay, if I show you the one Excel file, it will be more better. Just a minute. Okay, suppose I have a data set. Suppose I have some data set, suppose class. So this type of class, suppose I have the class for water, I have the class for, suppose, build up, I have the another class, suppose bare land, I have another class, suppose vegetation. Okay, I have this type of class, water, build up, bare land, vegetation. So now for this type of class, I need some property. So how I can distinguish? This is the water, this is the build-up, this is the barren land, this is the vegetation. So these things basically we just use help of property. So I need to set some property in my model. Suppose I take the some data from for the remote sensing, we use at the pixel value. Okay, we set the some pixel value, pixel value, pixel value. Suppose this pixel value can be band 1 or band 2, okay, band 3, okay, or band 4, okay, band 4. So now for the water, I simply choose some pixel value for the different band. For the build up, I choose some pixel value for the different band. For the barren land, I take some different band value. For the vegetation, I simply choose some different band value. So this is my property. So I use this property and further I simply classified this type of classes. Okay, so let's go try to work practically. So now I just need the training sample. So from this imagery, we can easily get the idea. So it's called the natural color. So basically naturally we find out this type of place have the vegetation, green color vegetation. We can easily get the idea. Naturally we find out this type of water body or lake. Okay, we can also use this type of place, it's a barren land. Okay, but it's a one band combination, but we can also use the different band combination to identify different types of feature from satellite imagery. Suppose if I just use this another band combination, suppose I just keep here near infrared, red and blue. So this is the another band combination, just apply. So now I can easily find out the vegetation, it shows a red color. I can easily find out the vegetation show as a red color, and water body show as a, this type of black color or dark color. So I can easily get the idea. This place I find out the water, this place I find out the vegetation, or if you check this type of place I find out the barren land or gray color, this type of color. Okay, and this type of place is the vegetation, red color. Okay, and this type of place I find out the water body. So this is the way. Suppose I want to use the another. Suppose I want to use short wave infrared one, then near infrared and blue, keep 98%. And apply. So this is another band combination we can use to identify you can see different types of feature. So vegetation we find out this type of green color, water body show this type of black color, and it universal, any place we can apply this type of band combination, then we find out this type of visualization. Okay, and identify vegetation, then water body show as a black color, dark color, or barren land show this type of color. Okay, so now we are use different types of band combination and identify different types of feature from satellite imagery. Not only for that, we also use at the band ratio. Okay, so if you simply search here band ratio, band ratioing in remote sensing. Okay, so there are also a lot of use to identify geological mapping. We also use it, or mineral detection. We also use the band ratio. Okay, you can see this type of band detect the mineral with frost absorption or clay mineral. So there are a lot of use in remote sensing for the band ratio. So you also try to read this from the history website, band ratio definition. Then get a lot of idea and different types of band ratio. It give you the different types of information from your satellite imagery. Okay, let me check from here. So you can see the band rationing, different types of vegetation. Okay, they are explain all of those. What is the band ratio? LST, TMMS, the band ratio. You also try to read this type of things, then you can get a lot of idea. Okay, so his type of band ratio give you his type of feature from the satellite images. So you can see that use this type of band ratio. So this band ratio help the cropland having a good vegetation and Campbell band with the river associated with it. Okay, so we can easily identify. Okay, so you also try to read this type of things later. Okay, so now we are use the different types of band ratio and also use the different types of band combination to identify different types of feature from the satellite imagery. So now I want to take the training sample because I want to apply the supervised learning. So how I can take the training sample? So for taking the training sample, just use the marker. You can also use at the rectangle. So marker is best to get the point. Click on the marker. So you can see it show the geometry. Click on here again. I put the name. Suppose it's a. I take the training sample for water, and I just feature collection and property. I set the property suppose class and set the value for 0. So I start from the 0. You can also start from the 1, 2, 3, no problem. So 0, it's a level. I set the level of training sample for water is 0. And then okay. So now we take the training sample. So I just use the band combination. I can easily identify this type of place I have water. Okay, from this satellite images. I can get the idea. So this type of black color indicating about the water body. So just simply click and take the training sample. And how much training sample I collect for each classes. So basically it also depends on your accuracy. Okay, so we also try to compute the different types of accuracy. Suppose producer accuracy, consumer accuracy. Further, if I face any problem in my accuracy or I find out the lower accuracy, then we need to increasing or decreasing the training sample. Okay, but first time we try to run more than 30 or 50. Okay, for a small study area or big study area more than 100 and then run. Okay, so it's a not big study area, we take suppose more than 30 and further if we check the accuracy and if I get the lower accuracy we try to increasing or decreasing the training sample for different classes. Okay, so I take this type of training sample for water. So then I take the another training sample. Suppose I take the training sample for suppose vegetation feature collection. Add the property. I put the property name suppose class and set the value for 1. Okay, I set the level or I set the pre-categorized data for vegetation. I set the level is 1. So now we can easily get this type of green color from our band combination. You can get the idea. So this type of green pixel indicating about the vegetation area. So just we simply take the vegetation. Training sample for suppose barren land or flow land. Set the property for class and set the value for 2. 2 we set the pre-categorized data barren land or this type of place, this type of color. And you can see this type of place, it also barren land, but it also work as a wetland. Okay, when you just use the band combination, you can get this type of color. So it's indicating about that your wetland, but this type of colors is the barren land, dry barren land. This type of color indicating. So I just march those top. Okay, then we take the training sample for suppose build up. Free. Okay. So now we try to apply suppose on natural color. So then we find out the build up is more better. So apply red, green, and blue. So if you can simply search on the Google, you find out lot of band combination. Okay, for the different feature, we can easily identify help of different types of band combination. So this type of place. So just take the training sample. Okay, so this is my training sample. So now all of training sample. So this type of training sample we are just used to train our model, and we need to extract the pixel value for this type of training sample. So for that we need to merge. You can see water, vegetation, barrier, and build up. We need to merge all of training sample together. So how I can merge? So for the merge, take a variable. Suppose I put the variable name is a sample equal. So water, it merge with vegetation, then merge with barren, merge with build up. Okay. So simply merge. Now if you check how many training sample you collect for all of classes, run the code. So you find out their total. If you check, so all of training sample you find out with their property. If you check, suppose this is the training sample, and what is the property? Property is the class 0. So this training sample I use to train the water class. Okay, so I set the pre-categorize. We can see. So this is the training sample for the class 1. For the class 1, I set for vegetation. So all of training sample we set the pre-categorize, and we simply set the label. Okay. So for my case, 0 is water, 1 is vegetation, 2 is barren land, 3 is build up. So now we need to create a data set. Okay. So need to create a data set. So this data set basically stored the band pixel value. Okay, this data set stored the band pixel value. So now we try to make the list the bands. Okay, suppose I just take a variable, suppose bands, and I want to use this type of bands. Okay, so I already keep the similar bands for all of Landsat 5, 7, 8, 9. So I want to use suppose blue, green. Okay, I just use this band, this optical bands, and then paste here. Okay, so this is my bands. So now what is my target? My target is that this type of training sample all of training sample or all of training point, extract the information for blue, green, red, near infrared, SWIR and SWIR2 reflectance value. It is struct for every point. It is struct. So for that, we use a function. This function called sample regions. To take a variable, suppose I put the variable name is that training. So call the image. So I want to use this image 2025. Okay. So this image is stored in a variable. This variable name is the image 1900 image 2025. Paste and put the select function. Select these bands. Okay, and paste here. And apply sample regions. Okay. And now we extract the information from here. So first argument is the collection. So I already defined my collection. So my collection is sample. It is started all of point. So I want to extract the information or reflectance value for all bands for my this type of points. So collection I define. Then we need to define the properties. So properties basically it's come from our property name. So you can say I set the property name is the class for all of different classes. So we can put any name as a property. I put the class, no problem. Then after properties, we need to put here the scale. Scale is the 30-meter resolution. So now if I just print and show you the results, suppose training. So now it show you that all of training dataset. We find out the full dataset. Basically, this dataset is stored the every single point's surface reflectance value for this type of bands. If you check, we find out this type of band pixel value. Just click on here. So you find out, you can see. So for this point, it extract blue reflectance value, green near infrared, red short wave infrared 1 and short wave infrared 2. It extract this type of information. Suppose you can see this property. This is the class 2. So it extract this type of information. So this is the another. It extract this type of information. So now this is my property. Okay. So I want to use this type of property and train my model. Okay, I just teach my model, and then this model just use their own experience and further classified the full satellite image and identify water body, build up, vegetation, and barren. So now this data set I need to apply. This data set we need to split. Suppose some data set I want to use to train my model, and some data set I want to use to test my model. Okay, so in the machine learning we need to train some data set. We are just use train our model, and some data set we also need to use for test our model, basically for checking the performance level of your model. Okay, so further we need to split this data set. So this variable is stored all of data set. So this data set I want to split. So from the split data set I just need to use some data. Maximum paper that use at the 70% data to train the model, and rest of the 30% data to test the model. Okay, or checking the performance level. So now take a variable, and then this. Okay, so and this 70% and 30% we need to take the randomly. Okay, randomly we select. So for randomly distribution, we need to use the another function. For randomly distribution, take a variable. So I put the variable name, suppose with random, and call this training. This data set I simply call, and I just randomly distribution. So for that use at the random column function to randomly distributed this data. So now this data set randomly distributed and stored in this variable. So from here just I spill the data 70% and 30%. So for that take a variable. Suppose train set, I just call the with random. So this thing is simply filter. So put here the filter art engine dot filter. I take the less than random 0.7, okay, less than 0.7, and then also take the another variable, suppose test set with random filter art engine filter. In this case we put here that greater than equal random greater than equal random 0.7. Okay, he's indicating about the rest of the 30. Okay, so we simply spill the train set and test set randomly using the random column function. So now this train set we are just use in our model, okay, and create the train our model, okay, and this test set we are used to check the validation of our model. Okay, okay, so just we are make a 10-minute break, then we'll start again. Okay, just make a break for 10 minutes.